In this presentation, we would be looking at supply chain attack in AI. Here are a few of the touch points we would be looking at: historical context, common patterns, past incidents, relevance to AI safety, defensive signals, and closing. A quick intro. A supply chain attack is an attack that exploits a trusted third-party tool, model, or service, and from that, it can silently infiltrate the main target. It's also known as value chain attack, third-party attacks, where a trusted third party get compromised, and that affects like the main or the primary or the services. This has some historical context of different supply chain attacks that have happened in previous years. C-Cleaner attack 2017. A software update was compromised and that pushed malware to over 2 million users. SolarWinds 2020, and attackers were able to inject malicious code into an update, also affecting thousands of organizations, and it also took quite some time to get detected. Movie Data Breach 2023, attackers exploited a zero-day vulnerability in the file transfer software. That also caused a data breach. What are common patterns in this type of attacks? The blind trust or partial trust, where the upstream components are assumed saved without verification or minimal verification. Silent propagation. Compromise spreads invisibly through dependencies, because this is expected as a form of update or form of software. So it sometimes can go undetected, which boils down to the third point: delayed detection. Both maintenance and end users sometimes realize too late. In some cases, they realize on time, and it also rings an alarm and shows how widespread it has gone. Scale. It ends up affecting very, very wide areas or wide set of users. Hidden trigger or backdoor. Almost in most cases, there's always like a backdoor or trigger or some malicious intent involved, and sometimes it can give a false sense of safety and it can resurface, and sometimes it can be properly swept out. Surface attacks in AI. What will be some examples of surface attacks in AI? Data. If the data set itself gets poisoned and that goes undetected, and it's also used to train the model. Models backdoored or tampered with. If weights itself get tampered with or backdoored, and that will affect downstream users who use the model and also see funny behaviors. Codependencies or packages. This can go both ways. If it affects the model, if the model is like downstream, compromised Python packages can affect that. And also this can go downstream. Once the model gets affected, it also affects downstream services using the model. Failure patterns in AI supply chain and how a weak link can turn into systemic collapse. Trigger: if the data sets or there's a weak vetting or weak checks or weak evals for those AI models. Breaking point: once that is compromised, and currently based on past performance, most of these models are well trusted upstream. And what ends up happening is there's a blind trust. Once a new model gets released, a lot of users use the new model, and in so doing, that leads to compromised data. Model silently propagates downstream as a lot of users keep using the new one. There's some malicious code or some malicious intent happening normally. Now, the impact is always hidden. It takes some time before it gets realized or detected, and that leads to systemic compromise of AI behavior at scale. Usually what follows after such detection leads to a bit of higher or tighter security checks, tighter safety, and new paradigms get implemented. Scenario, we'll keep this for the last to discuss an actual scenario that happened. Relevance to AI safety. How is this relevant to the whole AI safety? Safety starts with trust. If data model or code is compromised upstream, there's no amount of alignment of safeguard downstream that can fix it. Systemic propagation. A single poison model package can silently spread across fine-tunes, apps, and users, also causing risk at scale. invisible failure, backdoors and malicious triggers bypass normal evaluation. So there can be a false sense of safety as all looks fine, but once the backdoor get triggered, it shows that there is some funny behaviors happening. Zero trust is required. This is restated often that, especially for frontier labs, the use of zero trust should be actively applied. AI systems must verify provenance at every stage. Some of the defensive signals that has been in place, some are in consideration, or some has been proposed is safe serialization format, that's safe tensors compared to using Pico, data set provenance and checks, ensuring that your data set quality is top-notch, and also there are no set of harmful data there. Zero trust principle in terms of access and managing different parts of your system, considerations for model signing. Some models also use this. Continuous monitoring, ensuring that you have your flags in place to quickly detect funny behavior or anomalies. Reproducible pipeline to detect changes. This is to ensure to catch or be able to recreate the scenario, or in areas where this cannot be easily fixed, a rollback can be done. Here's a quick closing statement, but before we get to that, we would be going through the scenario. Now, for the scenario, we'd look at one from Reversing Labs, where a malicious model was discovered on Hugging Face. And the interesting thing about this, the link will be in the description down, is this model was initially flagged safe, or it wasn't flagged unsafe. So Hugging Face flag models are safe and unsafe. Not, you would see it in the platform when a model is flagged unsafe. So if it's flagged unsafe, you need to be aware that this model has some funny behaviors. Now, in this one, for this model or this set of model, it wasn't flagged unsafe, and that means it bypassed the security scanning mechanisms. And Ariel gave this technique a certain name because it appeared to be safe, since it doesn't have the unsafe flag. Now, Pico is not really something that is highly recommended because of such behaviors of having malicious code and stuff. So this lab ended up digging deeper, and they found interesting things of funny behaviors within this, and they make great suggestions. But the bottom line here is, if this was a quite prominent model, as you would see that how many downloads or how many people have used it, it would mean that whatever was found in this model, or the malicious code that was found, or the malicious thing happening here, would be running on the systems that actively downloaded or used this model at some point. And they also give suggestions to what to use and other things, and how to protect your ML models. And a good thing was they reported it, which is always a first step. Is once you notice such behaviors with malicious behavior and you have proof, it's very good to inform the third party. And in this case, they informed Hugging Face, and it was immediately removed. Since the malicious payload is inserted at the beginning of Pico stream, execution of the model wouldn't be detected as unsafe by Hugging Face existing security scanning tools. And they gave a set of good recommendation and what to do when you're using Pico and some other interesting things. So this is one interesting scenario where you see how a model from the third party all looks good, and you end up trying to use it, and there's a false sense of safety of how this looks fine, but it ends up happening to have some backdoor or some malicious packages inside. So what they did is they reported the malicious packages they identified, and they quickly responded, which is a good way. The incident response time was very fast, and within 24 hours, they also remove that, and they also made changes to their Pico scan tool. So Piccolo Hugging Face, proceed with caution. This were their recommendation. Generally, Pickle, there has been some interesting things around the use of Pickle, either to ban, to do nothing, or find a middle ground to try and implement security mechanism. But it's quite an interesting one to see how sometimes putting all the trust in the third party platform based on the fact that, yes, they do deliver on the terms of model they have on their platform, but sometimes they are like the very few 0.001% that slip through. And that can end up compromising your own systems. Now, to round it up, supply chain trust and verification will be as critical in AI as it has been in cybersecurity. And it's some part of this space that usually goes quite unnoticed till there is a major outbreak. So it's just interestingly what's putting a bit on light on it to also consider this. And looking at the historical context, the impact is always very wide and it has a very large surface area of impact. That's it for this demo. Let me know if you have any questions.